Welcome back. Time to take a look at the example in code of how shared pointers are actually working. So let me pull this up in Emacs. And just like last time, I created a number of samples. So we'll go to ModG, shared pointer CPP. And again, same thing. So here I've updated my printout routine to print not only the pointer using get, remember, here it's no risk, it's just for printing, as well as the use count to report how many owners exist for a shared pointer. The second thing I did is create a structure. So this structure is an object, and we've already seen structures with methods. So this is a structure called foo with one attribute, an integer, a constructor that initializes the integer, that's the second line, and finally a destructor, we'll see what that is, but this is a piece of code that is being called when the object is deallocated. Think of it as the same thing as the finalize in Java, in C++. We'll cover them in details when we cover classes really soon now. But for now, it's a way to make sure that we see when the block of memory is getting deallocated. Then after this, I basically have my main program. That's the first thing I want to show you. That's calling a routine test. And then saying, oh, we're done. We're printing out that we're done. And now we can look at test, right? Test is the interesting bit. So here it is in its full glory. It's saying we use the namespace, we create a shared pointer, and we initialize it. So it looks very much like the initialization of a unique pointer. Then I actually write to it exactly as if it was a raw pointer. So I'm using shared pointer as if they were a raw pointer. There is nothing special. Then I print out p and the value pointed by p. So I should see the shared pointer, its counter. Normally now there is only one owner, it's p itself. And then we should see that the value is 42. Now what I do after that, and we've seen that I have a couple of alternatives to play with, is that I can declare another shared pointer, for example z, and then do a plain vanilla C-style assignment. Now notice here that there is no transfer of ownership in the semantic of shared pointer. All we want to say is that there is one more owner for the object that p refers to. Now both p and z refer to it and are sharing it. Clearly once we do that, the reference counter for the object that p points to should be 2. So the mental model we develop when we are done with this line and about to be doing the printout would be that there is an object here that happens to be a foo. Then there is a manager for this guy that points to him. There should be 2 references, and I should have p pointing there. This pen is dying. I have p pointing there, and then I have q. I called it Q, no, sorry, I called it Z. I have Z pointing there. And Z is also pointing up, right? So we have this kind of a situation. So that's the mental model that you should have in your head by the time we hit this line. Then we print out P, we print out Z. In both cases, I'm printing the pointer, and I also print what Z is pointing to. So let's give that a try. Go in the shell. So this is now SP. SP for shared pointer. We run it. And what we see is that we start off with P with a pointer, and there is one owner of it, and the pointer is pointing to 42. Then we see that after the assignment, P has 2 owners. Yes, we have P and Z, and that's reflected by the value between the bracket because of my printout operator. And we see that Z after tells us, well, there are 2, and it also shows the value, and then it says we're done, right? So this is working out fine. Notice here that because I'm doing a shared pointer of integer, I don't really have quite yet the opportunity of playing with foo. So what I did here is not really a foo. I should be quite honest with you. This is an integer in this case, right? We've done that game with an integer, and the value is 42. The problem is, normally, when both P and Z die, the counter drops to 0, and this is deallocated. But you can't see the deallocation. We have no way of actually doing a printout when this and that are going away, which is why we're going to use a foo instead. So let's go to the second version of this program. I'm going to return here, and rather than allocating an int as we see here, I'm going to use a version of the test, so sp2 normally, that now is going to make use of that foo structure I defined. And here what we see is that we create a foo. Then we do as before an assignment, so we should have two references. And then there are a bunch of functions. So for now, I'm going to take these guys and simply comment them out, right? Comment region. So they're gone. I simply have these two things being done, and I could print out, for the sake of understanding what's going on, Q is, right? So that's okay, I want to see that. And that's really all there is to it. And from main, I'm calling test. So now it's clear that when I go out, I will have two references. This will no longer be an int, it will be a foo, right? Which means that when both my variable p and q, and this one is now called q, when both p and q die, the reference drops to 0, and that should get deallocated, right? So let's see whether this is what's happening. So this is sp2. So let's go back in the shell, compile sp2, and then we run it. And what we see is the printout q is, and indeed, we have a pointer and a reference counter of 2. So the counter is indeed 2. That's what we expect. And the next line we see is that foo, and we see that very same pointer. So this guy, right, is destructed. So the deallocation did happen, and then we have finally the we are all done message. So what I promised did indeed happen. When these two guys went out of scope, the counter dropped first from 2 to 1, then from 1 to 0, triggering the death of the foo object and the reclaim of the memory. So that's a simple idea. So now maybe it's time to actually uncomment these lines and see what they do. Here I'm going to call a function fun on Q. So what does the function fun do? It's here, fun, receive the shared pointer, and it actually prints that pointer again, right? That's all there is. So let's think about it. When I'm calling the routine, and the routine is called fun, I'm going to pass Q. What is the effect of that, you think? Well, it's not too bad. It's going to create another box Q. That's going to, of course, point, because this corresponds to doing an assignment, it's going to point back up there, which means that the counter that was 2 should go to 3. Now I have both p and q that exist within my test function, as well as the q that exists within my fun function. So when I'm printing from fun, when p in fun, it should tells me 3. When we're going to return from fun, this q dies, so this goes away, so the counter should drop back down to 2, right? So let's see whether this is what's happening. And we have the printout to attest for it. We are going to print this line again, and we will say after fun, q is, and we'll put an equal sign, so this is nice and properly indented. And let's go to the shell, compile, run. So what do we see? We see q starts off at 2 at the beginning, we know that. We see p in fun is 3. So yes, indeed, we have the value 3, but after the call to fun, after fun, q is, that is that q, is pointing to this, and this has 2 references. So the counter has indeed dropped. When I return from fun, this guy died, so this is all gone by then, right? This is all gone, and therefore the value dropped back down to 2, right? So that's what we were expecting. So this is a beautiful story. It's working exactly the way we expect it to. Now, here's another function, and you guessed what I'm doing here. I have fun2, and it's starting off being exactly the same thing as fun, right? So it's exactly the same thing as fun. So you know exactly what would happen if I uncomment that, if I say, oh, let's print before and after, right? We know what should be happening in here. It's the same story. It's going to go back up to 3 and then back down. So let's compile and run. And yes, we go 3, 2, 2, 3, 2. So that's exactly what we expect, right? Because we have 2 print out, the one after fun and before fun 2. and both should be reporting 2, and they do. And when we return from fun2, when we are in fun2, the counter is 3. When we return from fun2, we're back down to 2. So this is exactly what we are expecting. It's all nice. Now, of course, the fun thing to do with fun2 is to slightly change it. And of course, you know what I'm going to do? I'm going to make this a reference. Now, when this happens, should the counter go up? Well, of course, no, it shouldn't, right? We know that in this case, we're getting a reference to the shared pointer, and that should not, therefore, modify. So we should be uniformly at 2, the value 2 for the counter of usage for all the calls to fun2. So let's run that, and this is indeed what we see. Look at those counters. They're 2, 2, 2, 2. So inside fun2, the counter never climbs because we passed the reference. So be careful as to what you do. If you pass a value, it's okay that the reference go up. If you pass a reference, they won't, but you could modify the original here by doing a reassignment. Point in case, doing a reassignment is quite easy. You can actually do it by simply calling a reset. Reset kills a reference, right? So when I reset the reference on Q, now I will lose that 1 and the counter should drop to 1. Is that the case? Let's go, compile, check. And yes, now look at this, the counter is 1. So here, the counter didn't drop as a result of the death of Q. I forcefully reset Q, and the reset method does that. You could also assign the null PTR. It would have the same effect. Now, you know what will happen if I actually reset P as well. It means that I will lose my last reference, and we know what that should spell for us. It should spell the destruction of this guy and a null pointer. So let's do that, run it, and yes, indeed, I'm getting, after the line that says 1, I'm getting the message that the object is dying, and we see that the pointer is null with a reference counter of 0. So this is behaving exactly the way we would expect it. It's the proper behavior for this kind of setup. So that's it. That's what I wanted to do on this section. Now we're going in the next video to cover the last intricacy that's really worth digging our heels into when discussing shared pointer. See you next time.